Welcome back. Let's look at spiral matrix today. So number 54, spiral matrix is a medium. This is basically trivia knowledge. If you don't know this, you're not going to know this. So you should practice this at least once in case you get it in an interview. And if you do get it, good luck to you. So given an M by N matrix, return all elements of the matrix in spiral order. Trust me, you do this 2-3 times, you can probably get it in the interview for sure. So look at example 1. It goes from 1, 2, 3 to 6 to 9, 8, 7, 4, 5. So I guess one thing to take note of is it goes left, then it goes down, then it goes right, position wise, right, down, left, and then up, and then it recurses, right? So it goes right, down, left, up, right, down, left, up. Okay, so if you look at example 2, it is 1, 2, 3, 4, and then downwards, 8, 12, and then left, 11, 10, 9, upwards 5, and then 6, 7. Okay, so there's a very clear skill that you need to have when you're doing this, and it's the ability to iterate over some array, left to right, up to down, right to left, etc. Right? So let's say we have the one that is depicted there, 1, 2, 3, 4. We need some way to look at the indices. Let's say these are those indices, and these are the row indices, and we need some way to think through how to iterate over them. Now I've seen different approaches online, but they basically boil down to having some wall, right, where we respect the boundaries of this wall, right? So let's say the starting point. So what do I mean by wall, right? So when we're going right to left, we go 1, 2, 3, 4, right? So we finish this rightward angle, and the wall here is here, right? We want to stop at this point, and that's as far as we can go. We can call that like the right wall, I guess, right? And then on the way downwards, we're going to go 4, 8, 12, and it actually stops at this point in some way, right? That's kind of the down wall, the bottom wall. And you know what we've done actually is we've moved the top wall downwards, right? So when we did that first iteration, after we went down, we actually moved it downwards to here, right? So this wall, I'll just go ahead and cross it out. This wall gets rid of this availability, right? So the window shrinks more and more, right? And when we go from right to left, we're kind of moving this wall here, right? And then when we go up, we go from 9 to 5, right? And once we do the 9 to 5, we move this wall over here, and then we do the 6 to 7, and we go right here, right? So everything outside of these walls, I forgot to move this one up, but you get the idea. Everything out of these walls are the boundaries of our iteration, right? And that's the general idea, and that's why the skill is actually figuring out how to iterate on boundaries set by these walls, right? So that's the hardest part, and you actually have a choice here of where to set the walls. Like, where do you want these walls to be? For example, one thing you can do is say that the left boundary starts at 0, because in Python, that 0 is going to make iteration a little easier, right? Because when I do it for I in range, I could go from left to right. Now, what do I want right to be? That's a question that you can have for yourself. You can make right the length of the matrix, you can make it the length of the matrix minus 1, right? And that's going to determine whether you have this iteration going from range to right or range to right plus 1, right? So what does that look in the diagram? Now, we can start left here as 0, right? I'll just move this over here. Start left as 0. We want to start right as, now let's say it's the length of a row, then that means right's going to be 1, 2, 3, 4. It's going to be 4, right? So when I iterate over here, I can do for I in range left and right. And that works because 4, 4 would actually be here, this index, and it's exclusive of the index. So it's going to go from 0 to 3, right? So I is going to be 0 to 3 in this loop. Okay. Now, where that's confusing about the right and the left thing is imagine iterating from this 12 to this 9, right? So what indices do we want? Well, right is going to be 4. So you have to iterate from right minus 1. You want to iterate on the 3 to what's left. Left is 0, but it's exclusive, right? So like Python needs to be here. So you have to be at the -1. So you're going to be at left -1, right? Right minus 1, left, right minus 1, left -1. So you have to subtract 1 from both of them. It's a little shifted. Okay, so the other option is instead of making right 4, we can make left equals 0, right equals 3 as the last indexed that is valid, right? So now left is the first index that's valid, right? Or first and last are not good terms here actually, but both of these are indices that are valid. Maybe in your own mind it's easier to map that out. In my mind it's easier to map that out. These are the indices that are valid. So for an iteration going right, let's say we're going right, then it's just for I in range left to right plus 1, because I know that right is a valid index, plus 1 is going to allow me to do the for loop on it, right? So what about going left? Well, going left is for I in range right, because I know that right is a valid index. I know it's going to start at this 3 right here. All right, let me get rid of all these. So I know it's going to start at this 3 right here, and where do I want to go? I want to go to that 0, but I know it's going to be left minus 1. Right, so it's just, and it's going to be in the negative, right? So when we do this range, we're going to put a -1, so it's going to go backwards. And at least for me, that's more clear than this one, where we have to minus right, and then right minus 1, and then left minus 1, just for me. So I think for everybody, it's your choice here. You choose making the right the length of the list, or the length of the list minus 1, and the length of the list minus 1 means it's a valid index at this point, right? So my left is going to be 0, my right is going to be this. These are all going to be valid indices going forward, right? My top is going to be 0, and then my bottom is going to be the same situation, where it's going to be the length of the matrix, also minus 1, right? So go ahead and put results as a list here. Do I have to return results? I do. Okay, so return results is a list, and I'm going to just set my direction, a default direction. That default direction is going to be right. And then while left is greater than or equal to right, and the top is greater than or equal to bottom. Oh wait, so top is actually going to be top, but top indice wise is going to start at 0, so it has to be smaller than or equal to bottom. And then for these, I'm going to set the directions, right? So what are the directions here? So if I'm going right, then I want to iterate, right? Iterate from left to right +1, and collect things there. And then what I'm going to change is top, right? So top is going to go and increment by 1. And then the direction is going to change from right to down, right? So the direction cycle here is right, down, left, up, and then back to right, etc. Right? Okay, so the template here is if direction, iterate from x to y, z, increment or decrement, and then direction somewhere, right? The next direction. So this is the template. I'll move this to the top. Okay, so if I'm going right, I want that, right? So if I'm going down, then I want to go from the top level to the bottom, and the bottom is a valid index, so I want to add 1, right? And then I'm going to move, if I'm going down, the right wall, right? So, you know, so if I'm going right, I'm going to move the top wall down. Let's see if I can put this in the corner. Okay. So if I'm going right, I'm moving the top one down, right? So that's here, right? Top down. If I'm going down, I'm actually going to move the right wall closer, right? So the right wall will go that way, and then direction is going to go to left. If I'm going left, going from right to left -1 in the negative direction, right? And then if I'm going left, which wall am I moving? I'm moving the bottom wall up, right? So bottom and up means subtract here. And then direction goes to up. And if I'm going up, I'm going from bottom to top. And that's going to be top -1. And that's also going to be in the negative, right? So I'm going upwards here, right? And that means that the wall, whatever wall was here before, is going to move this way, right? So the left is going to be +=1, and the direction is going to go to the right. So that's the code, and we're going to return results. Now I actually have to write the code. I mean, I basically wrote the code here, but writing it out like this, for me, makes it so I don't have to focus on syntax, and sometimes it makes it easier, right? So So what is if right? What is if right? Right, so direction. So if the direction is right, I'm going to do something else. If direction is down, I'm going to do something else. Else if direction is left, I'm going to do something else. Else, at this point, direction is going to be up, and I'm going to do something else, right? So you could write each piece. You could write each chunk, or you could write the part of each chunk. Right, this is writing the part of each chunk. If I'm going right, the next direction would be down. Right, if I'm going down, the next direction is going to be left. If I'm going left, the next direction is going to be up, and if I'm going up, the next direction is going to be to the right. Perfect. Right, and then we need essentially we need a loop. We need a wall move. So each one is a loop, a wall, a loop, a wall, a loop, a wall, a loop, a wall. Right, so let's go right. So for I in range of left is right plus 1, because we want to be inclusive here, then we're going to store the results, right? So the results append whatever's here. So so we're iterating over the row, so the column is the one that's changing, right? So the valid row up here that we have is this up, this top, right? That's our valid row. So we're in the top row. So we want to say, what's the variable name? Matrix, right? So matrix top at I is what we're going to append, and then we want to move the wall, and the wall is going to be top, right? So top plus 1, direction's down. So what's the loop here? So for I, when we're going downwards in range top to bottom, and bottom is a valid index, so we're going to have to add 1, and the results append. So when we're going down, the column will stay the same, but the row will change. Right, so the row is here, I, and the column is going to be the right column. Right. When we're going down, the direction is changed, and then the right column gets moved to the left. I think you basically get it. It's just easy to make mistakes here, switching these rows and columns, going into the wrong direction, all these things. So going left, right, we want to go from right, which is a valid index, to left, also a valid index. So we want to subtract by 1 to make sure that we have that deal. And what are we going to append? What happens when we're going left? Row stays the same, column's changing, right? So we're going to append the matrix where the row stays the same, right? So the row is going to be the bottom row, and the column is changing. And we've iterated through the bottom row, and now the bottom row gets changed up. And that's actually the wall. It doesn't matter, but it's like loop, wall, direction, loop, wall, direction, loop, wall, direction. And I guess you could put that on a flashcard if you are so inclined. Loop, wall, direction. Okay, so what does it mean to go upwards? It's for I in range bottom to top, right? And top is a valid index. We do want to subtract 1. And we're going to append, and what does it mean to go upwards? The row change, column stays the same. Right, so the row here changes, and it's going to be left. The column changes, right? It's going to be, okay, so going backwards and forwards, right? So this is one bug that I have. None of these are going backwards. If I'm going right, I'm going forwards. If I'm going down, I'm going from 0 to x. But when I'm going left, I actually want to go from x down to 0, right? I want to go back. So let's make that a -1. If I'm going upwards, going towards 0, I want that to be a -1, right? So what's the wall here? Left, right? So left plus 1. And I believe this covers all cases. Let's run it, see if we have a syntax error. It's normal to have at least one. And we have one. Okay, so let's look at it. 1, 2, 3, right? It's actually a horrible way to look at it. Let's look at it like this. For row in matrix, print row. Okay, so 1, 2, 3, that's great, perfect. 6, 9, that's great. 7, 8, that's great. And then we got a 7 again. Oh wait, no, 7, no, sorry. So that's right, 8, 7, that's correct. And then we got to a 2, right? 2, 5. How do we get to a 2? That's wrong. So it's easy to get these little mistakes, right? When we're going upwards, how do we get a 2? So we're going from bottom to top, where bottom is this, and top is this, and I got left here, and what is left? Left is started see? You see this right here? Left is the row. It's not the column. So here is a perfect one. Here the row is fixed, the column is changing, right? So where did this 2 come from? 2, 5. I'm using these. It's kind of strange, but the left. Oh, that's weird. I would imagine append left. I would imagine that these actually had different oh, right, totally. So left is going to be 0, right? And 0 is the row here. So that's why it's going to be 5. It's going to be 2. Anyway, these should be flipped. There should be an I. This should be a left. So that's at least one problem. Okay, cool. There's probably some edge cases, like what happens if it's an empty list? Let's just length of matrix is 0, return an empty array, I guess. I wonder if there's a way to not make that mistake that I just made. I don't know. You could be kind of pedantic. You could say row equals top, column equals I, and then here you can say row column, right? I guess for some people that would be clear. Row column where row equals I here, column equals right. That might be more confusing for people, but you can imagine that that would clear it up for you. I guess it just requires some practice and some quick debugging. Let's submit it. There's probably another error we have here. Oh, great. So, looks good. I think you might see people do modding of this, right? So right could be, you can imagine that right is 0 and the direction is just increased, right? Direction plus equals 1, right? And then the direction is just modded in some way, so it cycles over 0, 1, 2, 3. For an interview, I don't think that matters. I mean, even for real life. You probably wouldn't do the string anyway. You'd probably use an enum to make sure that nobody makes a mistake here, towards the future. Anyway, fun problem. Hopefully you get the whole wall idea that I was trying to do with this diagram. This really is a problem about coding, graph traversal, balancing, indices, and before your interview you can make this decision up front. Which one do you like doing more? Setting the right as the length, or setting the right as the length minus 1, right? The valid indice method. Thanks a lot. I'll see you next time, and happy coding.